All right, good morning, pre-calculus. So this is 1.7. It's our last section in the chapter 1 notes. So get ready for your test. So today we're talking about sum, difference, product, and quotient rules of functions. So sum, adding, difference, subtracting. Product is multiplication, and quotient is division. So this should all be review, but we're going to talk about it anyways. If you remember, sum of two functions you can write as f plus g of x, or you can write it out as f of x plus g of x. It means the same thing. Difference, same thing. One important thing, make sure that you distribute that negative sign into the g of x terms. Or if it's g minus f of x, make sure that you distribute that sign to all of the terms in the f of x function. Product, that's where you're multiplying them. You're going to either see it as fg of x, or you're going to see it as f, a little closed circle, g of x. Okay, so this one you're going to have to distribute. You're going to have to FOIL if you need to. Some of them might be to the third power. So just make sure that when you multiply that you multiply correctly. Okay, and then this one, the last one here for right now is the quotient, and that's f divided by g of x, or f of x divided by g of x. Remember, g of x can't be 0 because if a denominator is 0, then it's undefined. You're going to want to factor and cancel and simplify as needed. Remember that if I have something like 4x squared minus 2, that's probably not a good one, minus 3 over 4x, okay, I can't cancel these 4's, and I can't cancel one of the x's. This is a binomial. It is one whole part. So if I were to factor another problem, so these don't equal each other. If I were to factor another problem down and get x minus 6 times x plus 2, and on the bottom I had an x plus 2, I could cancel those, okay? But remember, I can't cancel parts of a binomial. If there's an addition or subtraction sign in there, it stays together. You can't break it apart and just cancel various parts of it. It has to be the whole thing. Okay, so keep that in mind because that's one big error that that I see continuously. All right, so let's take a look at the first couple of problems. The first one says to go on ahead and add f plus g of x, and it gives me an f of x, and it gives me a g of x. So here I'm going to do 2x plus 1 plus, okay, so there's my plus sign. I like to write these so that they are lined up. That way I can combine my like terms just one on top of the other. So here I have x squared, 2x plus 2x is 4x, and a positive 1 and a negative 1 cancels. Now this I'm going to go on ahead and simplify. So I have x squared plus 4x. I can pull an x out, and I'm left with x plus 4. And you guys need to get in the habit of simplifying these. Okay? The only ones that you're not going to be simplifying are the multiplication ones. And the reason you're not going to simplify those is because if you've multiplied them out, there's no reason for you to now unmultiply them and take something out. Okay, all the other ones I want simplified. So f minus g of x, so we're going to do the same thing here. So we're going to do 2x plus 1 minus, now this minus sign, remember, has to be distributed to every single term in the g of x. So we're subtracting this whole thing. So that really becomes 2x plus 1, and then we're going to say minus x squared minus 2x and plus 1. Okay, so don't forget to do that. So now I'm going to have minus x squared. Those are going to cancel, and I'm going to have plus 2. I can't do anything to that. I can just leave it just like that. Okay, I could pull out a minus sign if I wanted, but it's not going to make a difference as far as if I start canceling stuff. So the reason that we want to make sure that we always simplify is because if we can cancel items, we want to make sure we can see that. Okay, so this next one, this is a closed circle. Okay, so that means f times g of x. Okay, so I'm going to do x squared times x minus 3. I have to distribute that x squared to both of these terms. So that's going to be an x to the third minus 3x squared. And once again, multiplying, I don't want to simplify these because if I simplify, then I'm just undoing the multiplication I just did. Okay? So this one I'm actually going to leave this way. Okay. And now it says, hey, let's evaluate for 4. Well, I could do it either from the beginning or from my answer. So I'm just going to go on ahead and do it from my answer since I've got it. So 4 to the third minus 3 times 4 squared. So 4 to the third is 64. And then I'm going to do minus, what is that? 3 times 16. Which is 48, I believe. Hold on, let me think a second. So I'm doing it in my calculator. Good, it is 48. Okay, I just wanted to be sure. All right, so 64 minus 48, and the answer I'm going to get is 16. So f dot g of 4, let me rewrite this so we can see it better. So f times g of 4 equals 16. So I'm actually going to get a number answer in that case. Okay. All right, so let's take a look at the next problem. So the next one says f divided by g of x. So I'm going to take the square root of x divided by the square root of 4 minus x squared. Okay. Well, I do not want to leave this as a radical. So I'm going to go on ahead and I'm going to multiply on both sides. Okay, so I'm going to multiply times the square root of 4 minus x squared over the square root of 4 minus x squared. And I'm going to get the square root of x times the square root of 4 minus x squared. And I could put these both under the same radical with parentheses if I wanted. Over, and here it's going to be 4 minus x squared. Okay, well, this I can simplify. So now I'm going to have, I'm writing too big here. I'm going to have the square root of x times 4 minus x squared all over 4 minus x times 4 plus x. Okay, so there's not a whole lot that I can do on that one, but you can see that it is something that I can factor out and possibly later on, you know, in some problems I would have been able to cancel. And so the next one says, hey, let's find the domain now. Well, we need to know that the domain relies on, in this case, the denominator, right? Because the denominator cannot equal 0. So I'm just going to look at this and I'm going to say, well, square root of 4 minus x squared has to be greater than 0. Okay. So I'm going to go on ahead and solve it. And I say, so I'm going to set just this 4 minus x squared greater than 0 because the square root sign really doesn't tell me a whole lot except for that whatever's under there has to be greater than 0. So now I'm going to size. So I'm going to subtract 4 from both sides, and I get negative x squared is greater than 0. Divide by negative 1, and I get x squared. Okay. And remember, if I multiply or divide by a negative number, that changes signs. So x squared is less than 0. And now I got to take the square root. Okay, what did I do here? Oh, I didn't subtract my 4. Come on, Katrina. All right. So there we go. So negative x squared is greater than negative 4. Divide by negative 1. So I get x squared is less than positive 4. And now I need to take the square root of both sides. So I'm going to get x is less than 2 or x is greater than negative 2. Okay, so when I take the square root and I change the sign on this to my negative, just like if I'm solving for absolute value equation, I have to change the sign, okay, when I write it out. So that is my domain, okay? So that's all I have to do for that one. Okay, so now for the next one, and do very similar. So I'm going to have the square root, except it's g divided by f. So Square root of 4 minus x squared over the square root of x. I'm going to multiply by the square root of x. And I'm going to get the square root of 4 minus x squared times the square root of x all over x. Okay, so same thing here for my domain. Okay, I know that x cannot equal 0 because I have to take the square root of it. Okay, so here, I'm just going to set it equal to x is greater than 0, and that's my answer. Okay, because it's a 0, I just know that it can't be equal to 0, and it has to be greater than 0. If it's less than 0, right? So if I had this x here and I had a number less than 0, I would get an imaginary number. Okay, I don't want imaginary numbers for my domain. Okay, so imaginary numbers are not valid for domain. All right, let's take a look at what we got next. So the next one is compositions of functions. So I was talking about when you multiply, you have that closed circle, but remember when you're doing compositions, you have this open circle here. Okay, so with compositions of functions, we are going to make sure that we see that open circle, and it can be written this way also, and I prefer to write it this way. That's just my method, because then it reminds me that I'm going to do this first, and then whatever this is goes into this function. Okay, so that's what this is saying here. So this says, hey, x is in the function g of x, and that g of x function is inside that f function. Okay, so wherever I see an x in this function, I'm putting this whole function in. Okay, and that's what this says too. It just skips that little middle step there. All right, so here it also says the domain of the composition of f of g is the set of all x's in the domain of g such that g of x fits into the domain of f. Okay, so we're going to have to kind of look at both of these, and we'll work some problems here. Okay, so very first thing, we're not going to look at domain yet. Let's go on ahead and just look at some problems. So the first one, my f of x is the square root of x, and notice x has to be greater than or equal to 0, because if I'm taking a square root, it has to be greater than or equal to 0. Okay. And g of x equals x minus 1, and it has to be x is greater than or equal to 1. Okay, and the reason that has to happen is if I plug this into here, this whole thing has to be greater than 0. And in order for that to happen, and greater than or equal to 0, in order for that to happen, this value cannot be less than 1. Okay, so now let's see how this works. So f of g of x. So that's f of g of x. What that means, okay, is I'm going to write my f function, so my f of x. Okay, so my f of x function is the square root of x. Now, anywhere I see an x, I'm going to put this value in. Okay, g of x, and I know what g of x is. G of x is x minus 1. Okay, so it's just an easier way of telling us to put something, right? So we could write this as f of x minus 1. It would mean the same thing. Okay, but we're just saying that we're putting another function in, and the other function is the stuff we're plugging in for x. So now, okay, I know that that is going to actually be, I'm going to rewrite this so that you don't get too confused. So f of g of x equals the square root of, but instead of x, I'm plugging in my g of x, which is x minus 1. Okay, and so that's my answer. And now it says, hey, if possible, let's find these values. So I'm just going to plug them in. I've already got my f of g of x. So now I'm just going to plug these values in for x. So 2 minus 1 is the square root of is the square root of 1. So that's just going to equal 1. Now notice I don't need the plus and minus because that square root symbol was already there. Remember, I only have to add the plus and minus if I'm trying to solve and I'm taking the square root of both sides. Okay, so 1 is my answer. Okay, f of g of 0. Okay, so what this is saying is that I am going to plug 0 in to this combination. But really what happens is I plug 0 in there first, and whatever answer I get there then gets plugged in here. Okay, it works either way. So I'm going to show you guys first me plugging it in as g of 0. So g of 0 would be x minus 1. Is what I would plug it into. So I would get 0 minus 1, and so I would get negative 1. Okay. So now if I do f of this answer, which is really g of 0, so f of negative 1, I'm going to get the square root of negative 1, which is no solution. Okay, so that's really what I'm doing. And I could do it this way also. I could say, oh, well, that's 0 minus 1, and that's the square root of negative 1. Okay, so it doesn't matter which one I do. Okay, but just remember that this means that I'm really plugging this 0 into this first, and then I'm plugging whatever answer I got there into this one. Okay. All right, let's try a couple more. So try this one, 1, 2, and 3. Okay, pause it, try it, and then let's see if you got the same thing I get. Okay, so hopefully you pause this. So I'm going to do my f of x equals x plus 2. And anywhere I see an x, I'm plugging in my g of x equation. Okay, so really that's going to be x is 4 minus x squared plus 2. Okay. All right, so now it says evaluate when x equals 0. Well, let's go ahead and plug 0 in. So 4 minus 0 squared plus 2, that's going to be 6. Evaluate when x equals 1. Okay, well, 4 minus 1 squared. Okay, that minus doesn't go with that 1. It's separate. Okay, minus the x, and the x is 1 squared, plus 2 is 4 plus 2 is 6, minus 1 is 5. Okay, go ahead and try this next one. Okay, same thing, pause it and try it. Okay, so now that you have tried this one, let's go over it. So this one is g of f of x, so same thing. So I'm plugging x into the f function, and then whatever I got there, I'm plugging into the g function. So my g of x is 4 minus x squared. Anywhere I see an x, I'm plugging x plus 2 in. So that's going to be 4 minus x plus 2 squared. So the first thing I need to do is square x plus 2. So that's really going to be, I'm going to write it up here so you can see it, x plus 2 times x plus 2, and I have to FOIL that. So first, x squared, outer plus 2x, inner plus 2x plus 4. Okay, so now I'm going to rewrite that, and I'm going to go on ahead and combine my like terms. So 4 minus x squared plus 4x plus 4. Now I have to distribute this minus sign. Okay, so that's going to be 4 minus x squared minus 4x minus 4. 4 minus x squared minus 4x minus 4. Those 4's are going to cancel. So my final answer is negative x squared minus 4. All right, so let's take a look at this next one. So it says evaluate when x equals 0, so I'm just going to plug it in. So 0, so negative 0 squared minus 4 equals negative 4. So let's plug in 1. So negative 1 squared minus 4 1 squared is 1, but that negative sign is still here, okay, because I squared my x value, which was a positive 1. Okay, that negative is not part of whatever my x value was. If this had told me x equals -1, okay, then that would be different. Okay, so -4, so that's going to be -5. Okay, so you've got to keep that in mind when you're working these problems. Okay, the x value we plug in just goes in for the x value. Okay, it doesn't include any signs that's with it there. Okay, those are completely separate because that's -1 times x squared minus 4. Okay, so that's -1 times 1 squared minus 4. Okay. All right, let's take a look at this next one and look at these domain. Okay. So here it says f of x is x squared minus 9 and g of x is the square root of 9 minus x squared. Okay, so it wants us to find the domain. So the very first thing I want to do, I need to find the domain of this right here. So I know that whatever is under that radical symbol has to be greater than or equal to 0. So now I'm going to go on ahead and solve it. So I'm going to get negative x squared is greater than or equal to -9 divided by -1. And I get x squared is less than or equal to 9. I have to take the square root of both sides. So I'm going to get x is less than or equal to +3. And then remember, I have to take the plus or minus. So when I take the minus, I change this and this sign. Okay, so just like if I was solving absolute value equations. Okay, so here, x is either less than or equal to 3, or it's greater than or equal to -3. Okay, so that is my domain. Okay, because that domain is what makes this true. And this has to be true in order for this to be true. Okay, now if there was something else in there that caused it to be not all real numbers, because this one is a parabola, okay, so it's all real numbers, then I would have to look at that also. But because this is all real numbers, then this fits. Okay, but if this had, you know, everything except 0, then I would have to say, you know, x is from -3 to 0, and then x is from 0 to +3. Okay, so I would have to break that apart. All right, let's take a look at this next one. So f of g of x. Okay, so I'm going to just write out what my f of x is. F of x equals 2x plus 3. Now, anywhere I see an x, I'm plugging in that g of x. So f of g of x, right? Anywhere I see an x, I'm plugging g of x in. Okay, and I know what g of x is here, so that is 1/2 x minus 3. And then I have that plus 3. And I like to write it like that, you know, because then I remember, you know, that I don't forget that end. That is my worst mistake that I ever make, is I forget those outside parts. Okay, so that's why I started writing it this way, so that I wouldn't forget those last parts. Okay, so now I'm going to go on ahead and I'm going to solve this thing. So 2 and 1/2 cancel. Okay, so right, because 2 times 1/2 is 1. So now I'm left with x minus 3 plus 3. Those cancel. And so I'm left with just x as my answer. Okay, so now I'm going to do g of f of x. So same thing. So g of x is 1/2 times x minus 3. Okay. And now anywhere I see an x, I'm going to plug in my f of x. Okay, so g of f of x equals 1/2. Okay, my x is 2x plus 3. And then I have that minus 3. Well, this time I'm going to do what's inside the parentheses first, because that makes that pretty easy. That plus and minus 3 cancel. And now I'm left with 1/2 times 2, which is just x. And hopefully you will recall from previous classes from Algebra 2 that this means they're inverses of each other. So I'm going to show you what that means just in case you forgot. So f of x equals 2x plus 3. if I change this to a y equals 2x plus 3, and then swap my x and y, and solve, I get x minus 3 equals 2y divided by 2, right, is the same thing as 1/2 times x minus 3, which is my g of x. Okay, so remember, if the compositions of each other both equal x, then they are inverses of each other. All right, we have just a little bit more, and then we are done with this chapter. Okay, so the next one says, express the function as a composition of two functions. In other words, we need to find the f of x and the g of x, and there's not just one answer, there's several different answers. So we could say, well, if we make f of x 1 over x, okay, then g of x would have to be x minus 2 squared, so that when we plug it in, it equals that. Or we could say this is 1 over x squared, and we could say that this was just x minus 2. Okay, either way works, and there's a couple other ways you could do it, okay, but there's two of the ways. So there's no one right answer on this question. All right, and then we have our last problem here. It's a word problem, and it's a very real life application of a word problem. So it says the number of bacteria in a refrigerated food N of T, capital T, equals 20 T squared minus 80 T plus 500, where 2 is less than or equal to T is less than or equal to 14, and that's the degrees Celsius. And if you've ever worked in a restaurant or pulled food out of a refrigerator, you know that it has to stay a certain temperature, otherwise it rots. As soon as you pull the food out of the refrigerator, your temperature starts changing based on your number of hours or the amount of time that it's been out of the refrigerator. So our temperature as a function of time, or T of T, is 4T plus 2. Okay, and T can only be, in this case, between 0 and 3 hours. Okay, so for different, different things, it might be different number of hours. When I take butter out of the refrigerator, I'll leave it out for 3 or 4 days until it's gone. And if it's not gone after 3 or 4 days, then if it's real butter, it starts to get a little rancid, and so I throw it out, right? But you have to really be careful about that, because milk, if you leave milk out for, 4 days, it's going to be massively rotten, and it is going to stink, and you're not going to want to rinse it out. So this is a really, good application, and this really does work. You see bacteria start to grow on stuff when you take it out of a refrigerator. Okay, so now let's go on ahead and let's find, so it says the composite, so it says find the composite in T of T, and what does it represent? Okay, so already we can tell what it represents. So the composite represents the number of bacteria after a certain number of hours. Okay, so we're going to go on ahead and find the composite by plugging it in. So in other words, in this N function, anywhere I see a capital T, I'm going to plug this in. Okay, so in my equation here, my N function, anywhere I see a capital T, I'm going to plug my capital T function in. Okay, so that's going to wind up being 20 times 4T plus 2 squared minus 80 times 4T plus 2, and then plus 500. And you can either, on this word problem, you can either work this out, but I'm not going to require you to work this out. You can also just leave it as is and not simplify it for this case. Okay? Because then eventually, we're really just wanting to know some different things here. So here it says the number of bacteria when T equals 2 hours. Okay, so here I'm going to plug 2 in for T. So 20 times 4 times 2 plus 2 squared minus 80 times 4 times 2 plus 2 plus 500 Okay, so I'm going to finish this out, and I'm just going to work this problem out. And if I plug it all in, I get 1,700. Okay, so I know now that after 2 hours, I'm going to have 1,700 bacteria in it. Okay. So the next question says, well, now what's the time when the bacteria count reaches 2,000? Okay, so I can do two things. I can either plug 2,000 straight into this and solve this first for 2,000, and then plug that into here and solve it. Or I can simplify this piece and just plug it in. Okay? But regardless, I have to set it equal to, not 3,000, I have to set it equal to 2,000. Okay, so 2,000 is going to equal all of this stuff that I have. Okay, so the first thing I'm going to do is I'm going to simplify this just to make life a little easier. So and I could always use my calculator too, but I'm just going to go ahead and simplify this by working the problem out. So I'm going to say 4t plus 2 times 4t plus 2. So bear with me while I do this. Here, I'll pause this and come back to you guys in a minute. You can see me done. Actually, no, I'm going to have you, so that you can, in case you don't get something. So that's going to be first is 16t squared plus 8t plus 8t plus 4. All of that is going to be times 20 minus 80 times 4t plus 2 plus 500. Now I'm not multiplying these through first because I'm going to go ahead and divide everything by 20. So that's going to give me 16t squared. So those will go away. Okay. So this 80 will be 4 and this 500 will be 25. Yeah. So now it's going to make life a little bit easier. Okay, so 16t squared plus 16t plus 4 minus 4 times 4t is going to be 16t minus 4 times 2 is minus 8 plus 25. Now I'm going to combine like terms and I get 16t squared. That's going to go away. I'm going to get negative 4 plus 25 is plus 21. Okay. So now I can just set that equal to 2,000 and solve. Okay, so I'm going to divide both sides by 20 and I get 100 equals 16t squared plus 21. Subtract 21 from both sides. Let's see. 100 minus 21, that's going to be 79 equals 16t squared. Divide by 16 gives me 4.9375 equals t squared. Okay, and now I have to take the square root of both sides. And I get 2.2 plus or minus equals t. Can time be negative? No. So my t then is only going to be about 2.2 hours. Okay. And remember, you could also do this on your calculator if you wanted to. So we could put in this original equation right here. So let's see, 20 parenthesis 4x plus 2 squared minus 80 times 4x plus 2 plus 500. And then for our y2, we would have to put 2,000 in. And here So let's see, let's graph it. We're not going to be able to see it right now. We're going to have to go a little bit further, a little bit higher, right? So for our window, our X-min and X-max will leave here for now. You know, we won't know. We've already solved it, so we do know. But if we didn't know, I would put my Y-min, you know, at 0, and I would say, well, I know that for 2 hours, it's 1,700. So it's got to be above 2 hours, okay? And it's got to be above 1,700. So I'm going to put my Y min at 1,700. And I don't know, my Y max, I would put it maybe 2,500. Okay, because then when I come up here and I graph it, okay, I can see where they touch, and you can see it touches at a negative and a positive spot. So then remember, if we're using this, we're going to go to our second calc, find our tools, and we're going to go down to find an intersection. Okay, now we're going to have to, let's see if I can, let's see, where am I at? I'm way up here. Okay, there we go. So I'm going to have to go here. Okay, and my second curve is this curve. Okay, and then I can choose where it intersects at. So my intersection in the positive side is going to be 2.222. Okay. So remember that that is also a possibility. You can use that. Okay. Oh. All right. Well, that is it for today. Have a great day, and I'll see you next time.